All right, let's play detective for a bit. Today we're tackling a case that, let's be honest, probably keeps a lot of you up at night. The case of the slow request. Now there's no chalk outline, but trust me, the culprit is hiding somewhere deep inside your application, and it's being just as sneaky.
You know the one, that question that just bounces around your head when things go wrong. Why is my application so slow? A user clicks something, you see that dreaded spinner, just spinning and spinning, and you know that somewhere, deep in the guts of your system, there's a bottleneck. But where? Where is it?
So to really understand why this is such a tough mystery to solve, we need to take a look at the scene of the crime. And for most of us these days, that scene is a really complex world of microservices.
Back in the day with the simple monolithic system, life was kind of easy. A request came in, it went from A to B to C, done. You could follow it. But now, with distributed systems, a single click can set off this absolute cascade of calls across who knows how many services. It's not a straight line anymore. It's a tangled web, a total black box. Good luck figuring that out with just logs.
So, how in the world do you see inside that black box? Well, you need a special kind of detective, one that has a pass to go anywhere and can follow a request no matter where it goes. What you need is distributed tracing.
And for our investigation today, we're bringing in a specialist. Our lead detective is going to be Google Cloud Trace. This is the tool that's going to help us gather all the evidence, all the forensics we need to find exactly where our performance problem is hiding.
Okay, so the first piece of evidence our detective collects is called the trace. Just think of this as the complete case file for one single request. It documents everything, its entire journey, every service it talks to, every operation, from that very first click all the way to the final response.
Now, when you open up that case file, you're going to find it's full of individual clues. In our world, these clues are called spans. Each span represents one specific piece of work, like a call to another microservice or a query to a database. It's one piece of a much bigger puzzle.
And how do we know all these clues belong to the same case? That's where the trace ID comes in. It's like a unique case number. Every single span, every little clue that's related to that one user request gets stamped with this same ID. It's the thread that ties the whole story together from beginning to end. Okay, our detective is on the case, and the concepts are making sense. So now, let's actually follow the evidence. We're going to track our slow request as it makes its way through a pretty standard 3-service application.
And the story begins. A user hits a button. That request smacks into our front-end service, and boom, the investigation is officially on. The clock has started.
Okay, what's next? The front end needs some data about the user, right? So it makes a call out to the user service. In our setup, that service is running over on Google Kubernetes Engine. This is the first hop, and our detective immediately logs it as a new clue, a new span in the case file.
But wait, there's more. The user service doesn't have the data itself. It needs to go get it from a database. And that database logic, it's all wrapped up in its own little service running on Cloud Run. So that's the final leg of this request journey, and it generates yet another span for our case file.
So, hold on a second. This brings up a really important question. We've got a service on GKE, another one on Cloud Run. Heck, they could even be written in different programming languages. How do they all report their clues in a consistent way that our detective can actually understand? They've got to be speaking the same language, right?
And that common language, that universal translator, is OpenTelemetry. It's this awesome open source standard that gives you everything you need to instrument your code. Basically, you're just adding these little watchers inside your application. This instrumentation is what actually gathers all the clues, the spans, and then sends them off to a back-end system like CloudTrace for analysis.
All right, the moment of truth. Our detective has done the hard work, gathered all the clues from every single service that was involved. Now it is time for the big reveal. Let's crack open this case file and see what the evidence is telling us.
And here it is, our whole case file, all laid out nice and neat in what we call a trace waterfall. Just look at this. The entire request took 850 milliseconds. We can see the front-end service was busy for almost that whole time. But what was it doing? Mostly just waiting. It was waiting for the user service, which, as it turns out, was also just waiting for the database service.
And there it is, the smoking gun. It's crystal clear. Our database service, the one running on Cloud Run, is our bottleneck. It ate up a massive 700 milliseconds of the total 850. We know exactly where we need to focus our energy to fix this. Case closed.
Now, solving one case is fantastic, right? But the real goal here isn't just to be a one-off detective. It's to build a whole system where these kinds of mysteries are just easier to solve from the get-go. This is the big leap from just tracing to having true observability.
So where do you even start with all this? Look, you don't have to instrument every single service all at once. Be strategic. Start with the services that are absolutely critical to your business. Then, go after the ones you already have a hunch are slow. And definitely instrument the edge services, the front doors where user requests first come into your system. Get the most bang for your buck right away.
And always remember, tracing is just one part of the puzzle. It's one of the 3 pillars of observability. Your metrics tell you what is happening, like CPU usage is at 90%. Your logs give you the super detailed line-by-line story, error connecting to the database. But it's the traces that tell you why it's all happening. They're the ones that say the CPU spiked because a slow database query in the user service caused a whole bunch of retries from the front end. Traces connect all the dots.
Look, with amazing tools like Cloud Trace and powerful standards like OpenTelemetry, you're not flying blind anymore. You have the evidence, you can follow every clue, and you can see the complete story of every single request. So the only question left is, what mystery are you going to solve first?